Okay. Do we have our unit circles out?
Yeah.
So the last thing we did on Friday together, guys, is we talked about the special ratios for sine, cosine, and tangent if it's a 45, 45, 90 triangle. The reason why I picked this one is because along our unit circle, we have angles that are triangles that are 45, 45, 90. So what you guys have to remember is, and we didn't mention this because class ended, but notice that for cosine and sine, guys, the cosine and sine of 45 degrees are both the same. Okay? Tangent of 45 degrees is 1. This is one that we really like because any math that involves 1 is going to be easy for all our problems. Okay? So what we're going to do is you guys have, as part of your cutouts, 2 mini versions of the unit circle. So I want you guys to grab one of the smaller ones because we're going to highlight some stuff right now. Okay, so what I want you guys to notice is in each quadrant, do you guys see how there's 1, 2, 3 like rays, 3 angles in each quadrant? Do you guys see that? The middle one in each quadrant corresponds to a 45-degree measure. So this right here, I want you guys to label right in the middle is 45 degrees. What is the equivalent radian measure of 45 degrees? Pi over 4, good. In quadrant 2, same thing. The middle angle corresponds to a 45 degree measure. So what is this measure right here that's in the middle in quadrant 2? 135, good. What is the radian measure of 135 degrees? 3 pi over 4? Good. Okay. In quadrant 3, this middle angle right here is how many degrees? 225? What's the radian measure? 5 pi over 4? And then quadrant 4. 315? Which is, what's the radian measure? 7 pi over 4. I want you guys to look at all the radian measures. You guys notice something in common. The pi over 4. That's important, okay? So the pi over 4s all have something in common. So what I want you guys to do is, if you guys have highlighters, I have highlighters on my desk if you guys need some. Can you guys highlight all of those rays one color? Okay, one of the last things we talked about on Friday was that X corresponds to cosine and Y corresponds to sine. So in the last problem we did in your notes, we said we found what the cosine of 45 degrees was and the sine of 45 degrees. What was the cosine of 45 degrees? Square root 2 over 2?
Yeah.
And this represents a little fraction, so I'm not going to draw it. And then same thing here, square root 2 over 2. So make sure we understand this. This means cosine of 45 degrees is root 2 over 2. You guys paying attention? And sine of 45 degrees is root 2 over 2. Outside of this parentheses, I want you guys to circle a number that's going to represent the tangent. What was the tangent of 45 degrees? 1. Okay. Now, the only thing that's going to change for the quadrants, which is why I wanted you guys to highlight them, is everything in quadrant 1 is positive. What changes in quadrant 2? Which one of these becomes negative? X. The Y is still positive. So this right here, these are going to be the same two numbers. The only thing that changes, George, the only thing that changes is the cosine becomes negative. So it's going to be the same two numbers, but X is negative. So it's going to be negative root 2 over 2 and positive root 2 over 2. Okay? Tangent is Y over X. You guys remember that? So if what's a positive divided by negative? A negative. So instead of 1, the tangent right here is going to be negative 1. Okay, is everybody with me? No? You get it? What happens in quadrant 3? What do we know about our points? They're both negative. So it's going to be negative root 2 over 2. Negative root 2 over 2. Tangent is Y over X. What's a negative divided by negative? Positive. So it's going to be positive 1. What do we know about quadrant 4? Y is negative. So it's going to be root 2 over 2. Negative root 2 over 2. What's a negative divided by a positive? Negative. So tangent's going to be negative 1. Okay? So I know this sounds really silly, but this is honestly how you guys are going to start to memorize this stuff. The pi over 4s, notice that all the numbers are the same. Root 2 over 2, root 2 over 2. The only thing that changes is where you are. Where you are tells you the signs. And in a few sections from now, if you guys took honors with me, you guys already know this. In a few sections from now, there's a little shortcut. I'm going to teach you guys to remember the signs. Okay? Cool? Questions? No? Okay. The next we're going to talk about is 30, 60, and 90s. What does equilateral mean? All the sides are the same. So I want you guys to draw a triangle where all the sides are length 2. Yeah, so something like that. So this is going to be 2, 2, and 2. Now what's cool is if all the sides are the same, that means all the angles are the same. Tell me, guys, how many degrees exist in a triangle? 180. So if they're all the same, what's 180 divided by 3? 60. Good. So 60, 60, 60. Okay? To prove what I'm going to prove to you guys, I'm going to, just for fun, I'm going to take this angle right here, and I'm going to cut it in half. So I'm going to redraw the picture right here where I take this angle right here and cut it in half into 2 triangles. So 2, 2. If I cut this in half, we know the whole thing's 2, right? So now this is 1. This is 1. This is still 60. This is still 60. How many degrees are each of these angles now? 30. This line we're going to assume is perpendicular. So what is the measure right here? 90. 30, 60, 90. Okay. So now what I'm going to do is I'm going to draw another picture. I'm going to take one of these triangles and just blow it up right here. Like redraw it, but bigger. Okay, I want to know what this side is. So Pythagorean theorems. So a squared plus b squared is c squared. Which side is c? Hypotenuse, which is 2, good. So 1 squared plus x squared is 2 squared. 1 squared is plus x squared is equal to 4. Subtract 1 from both sides. Square root. That means x is equal to square root of 3. Okay. All right, so let me prove to you guys what I want to prove to you guys now. So now that we know that, let's focus on 30 degrees. So talk to me. Sine is what over what? Opposite over hypotenuse. So what side is opposite of 30 degrees? 1. And the hypotenuse is 2. So the sine of 30 is 1/2. Cosine of 30 degrees. Adjacent over hypotenuse. So what side is adjacent to 30 degrees? Root 3 over 2. Tangent is what over what? Opposite over adjacent. So opposite of 30 is 1. 1 over square root of 3. Remember, we don't want a radical on the bottom, so rationalize, multiply top and bottom. So this equals square root 3 over 3. Okay. 60 degrees. What side is opposite 60 degrees? Root 3. So opposite would be root 3. Does the hypotenuse change? Nope. So root 3 over 2. Cosine of 60 degrees. Adjacent over hypotenuse. So what side is adjacent to 60 degrees? 1 over 2. Tangent of 60 degrees. Opposite over adjacent. Opposite of 60 we said was root 3 over 1. So it's just square root 3. Do you guys notice something about the sine and cosines? Yeah, there's change places, right? Tangent, this is the reciprocal of this. So they just flip upside down. Okay? All right. So now that we know all the 30s and 60s, we're going to do the same thing. With your mini unit circle, we're going to fill it out. And yeah, the other one, the other little one you have, and then we're going to transfer everything to the big one. Okay, so these also have a pattern, guys. All the 30-degree angles, everybody pay attention. The x-axis is right here, right? All the pi over 6s in our unit circle, because if you look at your big unit circle, we have a lot of pi over 6s. All the pi over 6s, pi over 6 corresponds to 30 degrees. All the pi over 6s are 1 away from the x-axis, the closest angle to the x-axis. So here, 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 and here. So right here, this is 30 degrees. This corresponds to pi over 6. So you tell me, so you guys are following along. How many degrees is this angle right here? 150? What does 150 correspond to? How many radians? 5 pi over 6. What's the degree measure here? 210. How many radians is 210 degrees? 7 pi over 6. In quadrant 4? 330, which is the same as 11 pi over 6. Okay, so do you guys notice how I did all these in green? So I'm going to highlight all those radii in the same color. Okay, this is going to follow a very similar pattern to what we just did. If we know what 30 degrees is, then we can find the other ones really fast. You guys follow me? Because aren't these all pi over 6s? So all of the coordinates are going to be the exact same. The only thing that's going to change is if it's positive or negative. So according to what we just did with the triangles, what is the x, remember, represents what? Is x cosine or sine? Cosine, right? Yeah, yes. Huh? I didn't hear him, sorry. Yeah. So cosine of 30 degrees is? Square root of 3 over 2. And the sine of 30 degrees is? 1/2. I want to do the same thing on the outside. What is the tangent? Square root 3 over 3. Okay? The only thing that's going to change, everything is the same except the signs change. So same numbers, which one becomes negative here, x or y? X. So this is going to be negative root 3 over 2 comma half. Remember, tangent is y over x. What's a positive divided by negative? Negative, so this is going to be negative square root 3 over 3. Okay, what about quadrant 3? Negative and negative. So negative root 3 over 2, negative 1/2. What sign is tangent going to be? Positive. In quadrant 4, which one's negative? Y. So it's going to be root 3 over 2, negative 1/2. What sign is tangent? Negative. Good. Okay, is everybody okay? I know this is going to seem really overwhelming at first, guys, but literally this is all this lesson is just learning where everything is at. Your homework's going to be really easy because you're just going to basically just use your unit circle. Okay? All right. All the pi over 3s are 60 degrees. So 60 degrees. Which color am I going to use? Yeah, I'm going to use purple. 60 degrees, pi over 3. All of your pi over 3s are the angle that is closest to the y-axis. So in this quadrant, this angle is closest to the y-axis. So how many degrees is this? 120. And this is 2 pi over 3. Down here, this angle is closest to the y-axis. What does this measure right here? 240, which is how many radians? Yeah, 4 pi over 3. Don't forget your pi. That's the best part. You don't like pi? What about for pi day? The crust, actually the crust is my least favorite part. Yeah, except for pizza. I like pizza crust. What's the measure right here? 300. What is the radian measure? Yes, 5 pi over 3. Okay, so I'm going to do the same thing. I'm going to highlight all of these in purple so it matches. Okay, same idea. Here, everything is positive. Look at our triangle. What was the cosine of 60 degrees? 1/2. And this was root 3 over 2. What was the tangent of 60 degrees? Square root of 3. Okay? I did this one. Am I going too fast? I can go faster. Really? What changes here? Which one changes sign? X. So it's going to be the same numbers, but x is negative. So negative 1/2 root 3 over 2. Negative root 3. Good. What about quadrant 3? They're both negative, so negative 1/2 negative root 3 over 2. Negative divided by negative gives me a positive root 3. Quadrant 4, y is negative. So 1/2 negative root 3 over 2. And tangent's negative. Okay. Now, please don't think I'm annoying. I want you guys to have a really nice unit circle like this. So if you guys don't have highlighters, please borrow some from a classmate or please borrow some from me. I want you guys to take like, I don't know how long it's gonna take, maybe like 10 minutes, 5 minutes. I want you guys to take everything what you guys just did in your notes and copy everything to your big unit circle. Okay? And please take me seriously, guys. You guys have to know this for our class. So this whole lesson, guys, understand, I'm not expecting you guys to have it memorized right now, but I need you guys to know how to use it to solve problems. Can you guys read that?
Yeah.
Okay, so what does this mean? We have 6 trig functions, right? Sine, cosine, tangent, cosecant, secant, cotangent. This is our angle. So, assuming you guys don't have this memorized yet, that's okay. Which quadrant is this angle in? Quadrant 1. So before we do anything, what do we know about all of our answers if this is in quadrant 1? They're all positive, right? So this is what I expect you guys to do. T is your angle. According to our unit circle, how many degrees is pi over 6? 30 degrees. So in other words, we're going to draw an angle that is about 30 degrees off of the x-axis in quadrant 1. And then I want you guys to draw a point right here. So according to our unit circle, what is the x and what is the y of this point? Yes. Yes. So do you guys agree this is x and this is y, right? You guys follow me? This just comes from a unit circle. Okay, I'm not trying to confuse you guys. What this problem's asking is, if we know this information, what are the 6 trig functions? So what is the sine of t? In this case, t is this angle, right? So which one of these numbers is sine? Which one? 1 over 2, right? Because sine is y. So sine is y, so it's 1/2. Okay? What's cosine? X. So the x in this problem is square root 3 over 2. The tangent, we can use our unit circle to check our answer, but remember, tangent is the same thing as y over x. So the y here is 1/2. The x is square root 3 over 2. Do you guys remember the little trick I showed you guys on Friday? The reciprocal, but do you guys remember what else I talked to you guys about? No? What's on the bottom of both fractions? So what happens to them? They cancel. The 2's can cancel. So you're left with 1 over root 3. But I can't leave my answer like that, so I'm going to rationalize. And I get square root 3 over 3. And if you look at your unit circle, isn't that what tangent of 30 degrees is? Okay. All right, are we okay? How do I find the other 3? Reciprocals. So what's the reciprocal of sine called? Cosecant. Good. No. COS is right here. Cosecant of t is the reciprocal of sine. So we're going to take our sine answer and flip it upside down. So it's 2. Secant is the reciprocal of cosine, so 1 over x. So if we take this answer and flip it upside down, we have 2 over square root 3, but we can't leave our answer like that, so we're going to rationalize. So you're going to get 2 root 3 over 3. Cotangent is the reciprocal of tangent. So guys, look, I want you guys to pay attention because this is important. I'm trying to save you guys some work. If I took my tangent answer and flipped it upside down, won't I end up with a radical on the bottom? Okay, but if you look back at our steps, we only did this step because we had a radical on the bottom. So in other words, do you guys see it? Like this is the same thing as this. This is just the answer that's more acceptable. So in other words, if I take this and flip it upside down, that'll be the same thing as this. So if I take this and flip it upside down, what do I get? Just square root 3. And if you guys don't believe me, if you flip this upside down and did all the steps, you would get the same thing. Okay? I was a senior in PreCal one time, way back in the day, in 2007. And I noticed that from doing all my problems. So I'm like, oh, when I teach this, I'm going to teach my kids that. You were just a twinkle in your parents' eye. Because you guys weren't even born yet. Some of you guys weren't even born yet. All right. We're going to pause here.